We've talked about dilations in the previous lesson, and in this lesson we're going to look at using our scale factor to not only, instead of determining whether it's been dilated, but to actually create a dilation. So we've talked about how, or what the definition of a dilation is, and we use a scale factor through a center point, and that's typically the origin, and that's going to be the case today. We're going to use that scale factor to multiply each coordinate in the figure by the scale factor, and that will give us our new image. So we'll take the pre-image, we'll multiply it by the scale factor, and that will give us the dilated image. And that works for both enlargements and reductions. If they just give us the distance of the side length or the length of the side of a figure, then we can just multiply that length by the scale factor as well. A couple of key concepts that we talked about in the previous lesson as well is the notation for dilations. K is my scale factor, so I'm just multiplying each coordinate in the vertex and each vertex by the scale factor. And then notice that the lengths of each side in a figure are also multiplied. So here we have our coordinate and then our new coordinate that's been dilated, but also the length of CD has been multiplied to give us the length of CD prime. If I know the lengths of the pre-image, then I can calculate the lengths of the image. And then remember that if the scale factor is greater than 1, then that's going to result in a dilation that is an enlargement. And if it's between 0 and 1, it's going to be a reduction. If it's equal to 1, then that's a congruency transformation. So let's look at 3 quick examples that go along with this. The first one is referring to a line segment AB, and it tells us that line segment AB has a length of 3 units and is dilated by a scale factor of 2.25. What is the length of A prime B prime? Does this represent an enlargement or a reduction? So first of all, let's talk about our scale factor. Our scale factor is 2.25. So remember, that is a scale factor that is greater than 1, which means that our dilation is an enlargement. To find the actual length of A prime, B prime, remember I'm going to take the length of my original and multiply it by the scale factor. So I'm going to multiply 3 times 2.25, which is 6.75 units. So that's going to be the length of A prime, B prime. Here it gives me the side lengths of my original pre-image, D, E, F. It gives me the side lengths of 1, 9.2, and 8.6. And it tells me my scale factor is 2.5. And it asks me to find the side lengths of the image now, D prime, E prime, F prime. So if I take each one, that's going to be from taking DE and multiplying it by the scale factor. So 1 times the scale factor is 2.5. And then I have EF. So to get E prime, F prime, I'm going to take 9.2 and multiply that by 2.5. Then I get 23. And then lastly, FD, F prime, D prime would give me, I've got 8.6 multiplied by my scale factor of 2.5, and that gives me 21.5. So fairly straightforward. So these are the side lengths of my image when I took my pre-image and multiplied it by the scale factor. Our last example gives us the vertices of a triangle. So we've got 2, -3, -6, 2, and 0, 4. So there's my pre-image. Let's switch to a different color. It tells me that the triangle is dilated by a scale factor of 0.5, so since that's my scale factor, it's going to be a reduction through the center. What are the image vertices? And we've already drawn the pre-image, so let's go ahead and figure out what the vertices are and draw the image. So each vertex then, I'm going to take each of the coordinates and multiply it by the scale factor. So 2, negative 3, that's going to become half of 2 is 1, half of negative 3 is negative 1.5. H prime, half of negative 6 is negative 3, half of 2 is 1, and J prime, half of 0 is 0, and half of 4 is 2. So I'm going to plot those points. I've got 1, negative 1.5. That's my G prime. H prime is negative 3, 1. And 0, 2 would be J prime. So as you can see, that is a reduction of the original figure.